Hello students, in business research and data collection, today we are going to discuss about measures of central tendency. First let us understand the meaning of central tendency. Central tendency describes the center or typical value of a data set. If large volumes of data are there, to know about that data set, we need to have a representative value. So, measures of central tendency gives a single value that represents the entire set of data points, and it helps in making comparisons. For example, when we say the average height of Indians is 5.5 and the average height of Americans is 5.8, it tells us that Americans are in general taller than Indians. So, measures of central tendency help us in understanding different data sets, and it also helps us in understanding where the most of data points in the distribution lie. So, there are several measures of central tendency. So, the tools which we use to calculate the central tendency are known as the measures of central tendency. So, there is arithmetic mean, geometric mean, harmonic mean, median, quartiles, deciles, percentiles and mode. All these are called measures of central tendency. The first one is arithmetic mean, and it is also known as mean. So, when we say we have to calculate average, it means that we are calculating arithmetic mean unless we are specifically mentioning that we are calculating some other average. It is very easy to calculate arithmetic mean. What we need to do is we have to add all the values in the data set and divide the total by the number of items in the data set. So, in formula terms, we say mean is equal to sigma x by n. Sigma x means sum of all the items in the series. For example, if a data set contains 2, 3, 4, 5, 6, 7, 8, the total is 35 and the number of items is 7, and when we divide 35 with 7, we get average of 5 or arithmetic mean of 5. When the data sets are normally distributed, mean is the best measure to calculate central tendency. So, we will know about the normal distribution and its characteristics, all those things when we discuss about the various distributions. For example, the variables such as marks, height and weights are normally distributed, because there will not be much difference between one value and the other value. There will not be any data outliers. Data outliers means the data points which differ significantly from the rest of data points in the data set. For example, in a data set, if all the items are nearer to 10 and if one item is 100 and the average is affected, because that outlier, the highest value 100 is affecting the arithmetic mean. So, we need to be careful about that. So, if outliers are there, the arithmetic mean is not suitable and it will not represent the data set. So, what are the advantages of mean? Let us understand. If the data are skewed, that means when outliers are there, the data are known to be skewed. When extreme lower value or extreme higher value is there, they are known as outliers. Mean is not suitable, as I have already pointed out, in such situations. So, advantages of mean are, it is very simple to calculate, as we have already discussed about that, and it is widely recognized. I have already mentioned that unless otherwise stated, average means mean. It takes all the data points into consideration in calculation, and it is the basis for other statistical calculations such as t-test, ANOVA, correlation, regression, all these measures are based on arithmetic mean. Arithmetic mean has several useful mathematical properties. For example, we use arithmetic mean in several further calculations. For example, in calculation of variance, standard deviation, etc., we calculate arithmetic mean, and it has relationship with other statistical measures, measures of dispersion, measures of central tendency such as median, mode, etc. In a normal distribution, that relationship can be clearly established. It represents all data points. As I have already mentioned, in calculation of mean, we add all the values. That means, we take all the values into consideration in calculation of mean. It serves as the foundation for many other statistical analyses and tests like hypothesis testing, regression analysis, probability theory, etc. It allows us to compare different data sets, I have already explained, and we can easily know about the shape of the data by calculating the mean. The mean is highly sensitive to extreme values. This is the disadvantage of mean, and the other disadvantages are, as we have discussed, when the distribution is skewed, that means when outliers are there, mean pulls in the direction of the skewness. For example, if left side skewness is there, mean is pulled by that, like that. We will discuss about it in clearly when we discuss about skewness. Two data sets with the same mean may look differently if there is lot of variance in the values of the distribution, and it makes the data sets become less comparable when there is variance. If the distribution is not normal, mean is not very suitable average. If the distribution is normally distributed, the mean is the best measure of central tendency. Now, let us discuss about the second average, that is geometric mean. Geometric mean is calculated by multiplying all the values in a data set together and then taking the nth root of the product, where n is the number of values in the data set. In simple words, geometric mean is the nth root of the product of n values in a data set. It is very easy, not as easy as arithmetic mean, but it is also easy to calculate geometric mean. So, if we have data set in which 2, 4, 8 are the values, we multiply these 3 values and we get the product 64. Take the cube root of the value, because we have taken 3 items. So, it is 4 and the geometric mean is 4. It is useful in calculation of growth rates such as average rate of return on investments, population growth, economic growth, etc. That means, when we need to calculate compounded growth rates, geometric mean is the best average. It also is useful when we calculate rates of change, and in index numbers also we can use geometric mean. It is less affected by extreme values or outliers as compared to the arithmetic mean. It is very useful when dealing with rates of growth. When the data are skewed, GM provides a better measure of central tendency as compared to arithmetic mean. The geometric mean is only applicable to positive values. This is the disadvantage of geometric mean. If the data set contains 0 or negative values, we cannot calculate geometric mean. For symmetric distributions, the geometric mean may not provide any significant advantage over arithmetic mean. So, in such cases, it is better to calculate arithmetic mean. It tends to underestimate central tendency in a normal distribution, hence we calculate arithmetic mean. Harmonic mean. The next one is harmonic mean. It is the reciprocal of the arithmetic mean of the reciprocals of the data points. So, it is a little bit confusing, let us understand it clearly. Reciprocal means a number which is the reverse of inverse of that number. For example, reciprocal of 10 is 1 by 10. In mathematical terms, the reciprocal of a number x is 1 by x, meaning you divide the number 1 by the number, then you will get the harmonic mean. The harmonic mean of a data set with n values x1, x2 like that up to x1 is calculated as harmonic mean is equal to n by, that means we in arithmetic mean we use n as the denominator, here we use the number of items as the numerator, that is divided by the sum of the reciprocals of the numbers, that is 1 by x1 plus 1 by x2 plus 1 by x3 like that, then we will get the harmonic mean. What are the uses of harmonic mean? Let us understand that. It is ideal for data sets involving rates, for example, speed, efficiency or financial ratios. In such cases, harmonic mean is useful. For example, in speed, if one travels some distance of different speeds, for example, while going, if he goes at a speed of 60 kilometers and while coming he comes at a speed of 70 kilometers, we can calculate the average speed by using harmonic mean, and in such cases arithmetic mean is not suitable. So, when the data points are inversely related to each other, such as calculating the average of ratios, we use harmonic mean. Data with extreme variations, harmonic mean is more useful because it is less sensitive to large outliers and extreme values than the arithmetic mean. So, let us now understand advantages of harmonic mean. Harmonic mean gives more weight to smaller values, which can be useful when small values have a higher significance, like in rates or efficiency measurements. Useful when data represents rates or ratios that are inversely proportional. What are the disadvantages of harmonic mean? The harmonic mean cannot be calculated if any value in the data set is 0, because we cannot divide 1 with 0. So, because division of 0 is undefined, in many cases it undervalue large values. Because it gives more weight to smaller values, the harmonic mean may undervalue larger data points, and it makes the harmonic mean less appropriate when the larger values are more meaningful in a particular context. It is not suitable for all types of data. It is most effective when dealing with rates or inverse relationship, but not for general data sets. The next one is median. Median is also known as a positional average, because we identify the average based on its position in the data set. The median is the middle value in a data set when the values are arranged in ascending or descending order. Since the value of median depends upon its position, as I have already pointed out, it is known as a positional average. It is the value which separates the higher half of the data set from the lower half of the data set. In other words, median divides the distribution into exactly 2 equal parts. To calculate median, first we have to arrange the data in ascending or descending order, and then we have to find the middle value of the data set. If the data set has odd number of values, the median is the value in the middle. If the data set has even number of values, the median is the average of the 2 middle values. For example, the median of 8, 5, 7, 2, 4, 6, 3 is 5. What we have done is, we have arranged the data in the ascending order and found the median. Uses of median: it is resistant to outliers. In the case of arithmetic mean, we discussed that arithmetic mean is affected by outliers, extreme values, but median is not affected by the outliers. It represents the middle value in a data set. So, even if there are high or low values, they do not affect the median. Better, it is better for skewed distribution. Skewed distribution, when outliers are there, it is called skewed distribution. Hence, if the distribution is skewed, median is the best possible average. It is not pulled in the direction of the skewness like the mean. It is a robust indicator of distribution shape. A large gap between the mean and median suggests that there is skewness in the data, and it is applied in non-normal distributions. For data that does not allow a normal distribution, median gives a better understanding of the central location of the data. But median has some disadvantages. It ignores data spread. For example, if there is lot of difference between one value in the data set and other value in the data set, it will not consider such differences as in the case of mean, because median depends upon the position of the value and not based on the quantum of the value. So, the median ignores the spread of the other data points and considers only middle point. It is less sensitive to changes in the data. For example, if instead of 10, if we replace it by 100, the median is not changed, because the position of the median is not changed in the data set. The median looks only at the middle value, and even small changes to values from other center might not affect the median. It is less precise in small data sets, because if only number of items in the data set are very small, median is not suitable, and it can be misleading if there are just a few or large outliers. And it is very difficult to calculate in large data sets also. If the data set has huge volumes of data, then median may not be suitable. When the data set has even number of elements, we are only finding out the approximate value of median, because we are taking the average of the two middle values. This is another disadvantage of median. And there are other positional averages which are related to median. They are called quartiles, deciles and percentiles. You must have listened to percentile. For example, 100 in IIM admissions, in CAT examination, the score is 100 percentile, like that they say. So, now let us understand what is meant by these quartiles, deciles and percentiles. Quartiles divide the data set into 4 equal parts. Unlike median, median divides the data set into 2 equal parts, and quartiles divide the data set into 4 equal parts. To divide the data set into 4 equal parts, we need to have 3 quartiles, and there are 3 quartiles: quartile 1, quartile 2 and quartile 3. Quartile 2 is nothing but median, and hence we calculate only quartile 1 and quartile 2. Quartile 1 is referred as Q1 and quartile 3 is referred to as Q3. The first quartile 1 is also known as the first quartile. It separates the lowest 25% of the data from the other data set. It is called the lower quartile. In simple words, 25% of the data is below quartile 1. So, how to calculate quartiles? Let us understand the procedure. As in the case of median, we have to arrange the data in ascending order in the case of quartiles also. It divides the number of items in data set, we divide the number of items in the data set plus 1 and by 4. For example, the formula is n plus 1 by 4. For example, if the items in the data set are arranged in ascending order as 4, 9, 12, 16, 25, 35, 49, 73, 89, 98 and 100, there are 11 items. Hence, 11 plus 1 is equal to 12. 12 divided by 4 is equal to third item. Third item is 12. Hence, Q1 is 12. Practical utility of quartiles. So, we are understanding about the calculation of quartiles. Now, let us finish that first. So, as I already pointed out, Q2 and median are one and the same. So, the same procedure which we adopt in the case of median, we adopt for the calculation of Q2 also. Q3 is, instead of n plus 1 by 4, we multiply n plus 1 with 3 and then divide it with 4 in the case of Q3. So, for example, in the above example 11 items are there, 11 plus 1 is equal to 12, 12 by 4 is equal to 3, 3 into 3 is equal to 9. So, 9th item is 89 and hence the Q3 value is 89. What is its utility? Let us understand the utility of quartiles. They help us in several practical applications. For example, to assess student performance, to identify underperforming or top performing students, we can calculate Q1 and Q3. For risk assessment in investment portfolio analysis and performance benchmarking, also we use quartiles. To segment the customers in marketing also we can use quartiles. In quality control in manufacturing also quartiles can be used. So, what are the limitations of quartiles? Quartiles do not consider all data points in the data set. They do not show the full shape of the distribution. They are not ideal for small data sets as in the case of median. Now, let us understand deciles. In the case of quartiles, they divide the data into 4 equal parts and deciles divide the data into 10 equal parts. So, hence there are 9 deciles D1 to D9. Each part represents 10% of the data set. For example, D9 means 90% of the data set is covered by D9. To calculate deciles, we use the same procedure as we have used in the case of median and quartiles. So, first we divide the number of data points in the data set plus 1 and divide it with 10. For example, the fourth decile is 4 into n plus 1 by 10. If there are 9 items in the data set, fourth decile is 89 plus 1 by 10, that is 9 into 4, that is 36th item. It provides a more detailed analysis than that of quartiles. Deciles provide more description of the data, because we calculate 9 deciles. In the case of quartiles, we calculate only 3 quartiles. So, percentiles. Next one is percentiles. Percentiles are values that divide a data set into 100 equal parts and each represents 1% of the data. There are 99 percentiles. For example, P1 is first percentile, that means it explains 1% of the data set, and P99 is the value below which 99% of the data falls. As I have already mentioned, the calculation of percentile is similar to deciles and quartiles. The only difference is, instead of n plus 1 by 10 or n plus 1 by 4 or n plus 1 by 2, we use n plus 1 by 100. Percentiles are useful in ranking and benchmarking. For example, a student in the 90th percentiles of a test scored better than 90% of all students. The next average is mode. Mode is the value that appears most frequently in a data set. Most frequently occurring value is called mode. For example, in the data set 3, 5, 7, 3, 8, 9, 3, 3 is repeated 3 times, all the other values repeated only 1 time. So, hence the mode of the distribution is 3. The mode is because it appears more often than any other number. If all numbers appear for the same number of times, there is no mode in the distribution. If there is a tie for the most frequent value, for example, if more than one value repeats equal number of times, then we say that the data is bimodal or multimodal. If there are only 2 values which are occurring at the same frequency, it is called bimodal distribution. If more than 2 values appear equal number of times, it is called multimodal series. What are the practical applications of mode? Let us see. In business, mode is very useful to identify popular products or customer preferences for inventory making inventory management and marketing. For making marketing strategies, mode is useful. I will give a simple example. In a shoe mart, you find most of the shoes having a number of 7 or 8, because many people have the foot size of 7 and 8 and very few people will have more than that or less than that. Hence, they keep more variety of shoes in 7 and 8 sizes. In education field also, mode is useful because it helps tracking common test scores and student performance levels. In transportation, we can find out the most common commuting times or routes for traffic management with the help of mode. In social media, we can analyze popular hashtags with the help of mode. Why should we study measures of central tendency? Let us understand. We have studied several measures of central tendency now. Why should we study these measures of central tendency? The first reason is, if the data set are given to you, from that you may not be able to understand anything. You have to summarize the data into a single figure which represents the entire data set. So, the methods of central tendency, measures of central tendency help us in understanding the data set by summarizing the data set. And as we have already discussed, the two data sets or more than two data sets can be compared with the help of measures of central tendency. And measures of central tendency also help us in decision making. I have already explained you several examples where measures of central tendency can be used, and it is measures of central tendency particularly mean the foundation for more advanced statistical analysis. For example, in hypothesis testing, for testing t-test or ANOVA, we use mean. Similarly, in calculation of regression, multiple regression, we use arithmetic mean. And for communication of data insights, the measures of central tendency are helpful. I have already mentioned, when we say the average height of Indians is 5.5 and average height of Americans is 5.8, we can easily say that the Americans are taller than Indians. However, measures of central tendency do not explain the entire thing about the distribution. We have to supplement them with measures of variation and measures of skewness, because measures of central tendency give us only central or typical value of the distribution, and they do not reveal how the data is spread or distributed. So, to understand the spread of the data, we have to calculate the variability in the data set, which are called measures of variation. And the second one is how the distribution is, whether it is normal or skewed, or left skewness is there or right skewness is there. To understand that, we have to calculate skewness, and the presence of outliers are not captured by the measures of central tendency. Therefore, measures of central tendency should be used alongside measures of dispersion and other statistical tools for a comprehensive analysis. To sum up, measures of central tendency help us in understanding the central value of the distribution, and it is the representative of the entire distribution, and we can understand the data set by calculating the measures of central tendency. Each measure has its own utility, and we have to understand where to use which measure of central tendency, because otherwise we may get the results which are not desired by us. So, where to calculate arithmetic mean, where to calculate geometric mean, and where to calculate harmonic mean, we have to be very cautious. Thank you very much.